Very good morning, students. Am I audible? Students, am I audible? Okay. So, students, very good morning. Today we continue our lecture with the same Fourier series and with the topic exponential function. Okay. So, before going to start the Before going to start the example of exponential functions, uh, I want to confirm the answer of the yesterday's questions example. Okay, so my yesterday's question, I'm going. Has anybody did the homework? Yes, Palak. I'm going to.
Yes, ma'am.
So what is the question of the yesterday for homework?
Uh,
That is
f of x is equal to
yes,
pi minus x by 2
plus.
and
So what is the value of a?
0 to 2 pi.
Yes, in the
Is
limit 0 to 2 pi. So what is the value
uh,
of a0?
0, ma'am.
Yes, good. And what about an?
It's also 0.
Yes. And for bn?
Bn 1 by n.
1 by n. Yes, absolutely correct. So students, the value of a0 is 0, an is 0, and bn is also 0. So your function f of x is summation n 1 to infinity. Bn, the value of bn is 1 by n into sine nx, right? So this is your Fourier series in the form of summation, and you can also represent in the form of sin x upon 1 sin 2x upon 2 plus sin 3x upon 3 up to so on, like this way. Many students are giving answer in chat box also. Yes, it is correct. Okay, so thank you students. Many students have did their homework. Thank you. So we'll move with the another topic, that is Fourier series for the exponential function. But before going to start the example, I want to recall some formula, that is the integration of e raised to ax cos bx dx is e raised to ax upon a square plus b square. Here a cos bx plus b sin bx, right? And here e raised to ax sin bx dx, that is e raised to ax upon a square plus b square a sin bx minus b cos bx. Okay, so this formula is helpful to you for the solution of today's example. And the values, that is cos 0, cos 2n pi, cos 2 pi, all are 1. Cos n pi is minus 1 raised to n. Sin 0, sin 2n pi, sin n pi, sin 2 pi, all pi and sin 0 are 0. Okay, so please keep in mind all both formula and all the values. Now let's start with the example, that is find Fourier series of f of x is equal to e raised to ax in the interval 0 to 2 pi where a greater than 0. Okay, so this is our question. As I said, our function is exponential. So for the solution, our main formula for the Fourier series, that is a0 by 2 summation n 1 to infinity an cos nx plus bn sin nx, right? Now let's start with the formula of a0. The formula of a0 is 1 by pi 0 to 2 pi f of x dx. So 1 by pi 0 to 2 pi. Our function is what? Our function is exponential function, that is e raised to ax. So here e raised to ax dx. Now the integration of e raised to ax with respect to x is e raised to ax upon a, right? And the limits are 0 to 2 pi. So a0 is equal to 1 by pi. Here a is constant, so I put out of the bracket. And if I put my upper limit, so my first term is e raised to 2 pi a. Okay, a into 2 pi. So e raised to 2 pi a minus e raised to a into 0. So e raised to 0. So the values are 1 upon pi a e raised to 2 pi a minus 1. Okay, have you any doubt for the value of a0? This is the value of a0. Have you any doubt? Okay, so let's move with the value of an. An equal to 1 by pi 0 to 2 pi f of x cos nx dx, right? Now 1 by pi 0 to 2 pi, our function is exponential, that is e raised to ax cos nx dx. Okay, as I told you, the integration of e raised to ax cos nx. Okay, so e raised to ax upon a square plus n square, the bracket a cos nx plus b sin nx. Okay, and the limits are 0 to 2 pi. Students, we did our integration with respect to x. Okay, here 3 times x in the power of e, the theta of cos, and in the theta of sin. So we have to substitute our upper limit 3 times, then minus, we have to substitute our lower limit 3 times. Isikasuri, B is an, yes. Here, as in our original formula of an, we have to write cos nx only. Okay, so here we replace by n. Yes, this is n sin x, right? This one is n sin x, because here in the place of b, nx. Okay, thank you, dear. So 1 by pi, I am going to apply my upper limit, that is e raised to 2 pi a upon a square plus n square and into a cos 2n pi. Cos 2n pi is 1, right? And sin 2n pi is 0. So n into 0. Okay. So this is the value of the upper limit. Now for the lower limit, if I substitute my lower limit, that is e raised to 0. So 1 upon a square plus n square, right? A cos 0 is 1 and sin 0 is 0. So n into 0. So this is the value for the lower limit. So after simplification, I have a into e raised to 2 pi a upon a square plus n square minus a into a square plus n square, because these both term will be 0. So a e raised to 2 pi a upon a square plus n square minus a upon a square plus n square, right? So if I get a upon a square plus n square common, then my answer will be a upon pi a square plus n square, and the remaining term is e raised to 2 pi a minus 1. Okay, so this is the value of an. This is the value of an, right? Now, have you any doubt for the value of an? Have you any doubt? If you have any doubt, please confirm in the chat box. Okay, okay, thank you. So we'll move with the value of Bn, that is, okay. So value of Bn is 1 by pi 0 to 2 pi f of x sine nx dx. So 1 by pi 0 to 2 pi function f of x is e raised to ax sine nx dx. And as per the formula of e raised to ax sine bx, here b replaced by n. So e raised to ax upon a square plus n square, here a sine nx minus n cos nx, right? And the limits are 0 to 2 pi. So 1 by pi, I am going to apply the upper limit, that is e raised to 2 pi a upon a square plus n square. Okay. And if I am going to substitute 2 pi in the place of this x, then I have sine 2n pi, and the value of sine 2n pi is 0. So a into 0 minus n. Here cos 2n pi and cos 2n pi is 1. So this is the value for the upper limit. Now for lower limit, e raised to 0 upon a square plus n square. Same, sine 0 is 0 again, minus n cos 0 is 1. So this is for the lower limit. Now 1 by pi. Students, our first term is 0, 0 minus n. So please keep in mind this one is minus term. So minus n e raised to 2 pi a upon a square plus n square, right? Now here minus minus plus. This term is 0 and minus minus plus. So plus n upon a square plus n square. So if I keep n upon a square plus n square common, then I have n upon pi a square plus n square, and the rest term will be 1 minus e raised to 2 pi a. Okay. So this is the value for Bn. Now we are going to substitute all three values of a0, a and bn in our formula for the Fourier series, that is a0 by 2 summation n1 to infinity an cos nx plus bn sin nx, right? Now what is the value of a0? The value of a0 is e raised to 2 pi a minus 1 upon pi a. This is the value of an, and this is the value of bn, right? So the value of a0, that is 1 upon 1 upon pi a, here 2 pi a, here e raised to e raised to 2 pi a minus 1. Okay. Now summation n 1 to infinity, the value of a n is a upon pi a square plus n square e raised to 2 pi a minus 1 into cos nx and plus summation n 1 to infinity n 1 minus e raised to 2 pi a upon pi a square plus n square sin nx. So this is here you may write e raised to x, it's up to you. So this is the formula, or you can say this is the Fourier series for the given function e raised to ax. No need to the further simplification more. Okay. So students, have you any doubt in this example? Okay. So we'll move with one more exponential example, that is find Fourier series for f of x is equal to e raised to minus x in the interval 0 to 2 pi. Okay. So let's start with our original formula, that is f of x is equal to a0 by 2 plus summation n 1 to infinity an cos nx plus bn sin nx. Okay. So let's start with a0. What is a0? 1 by pi 0 to 2 pi f of x dx. And what is our function? Our function is e raised to minus x dx, right? And the integration of this e raised to minus x is what? E raised to minus x upon minus 1. Limits are 0 to 2 pi. So a0 is equal to minus 1 by pi. If I substitute my upper limit, that is e raised to minus 2 pi minus e raised to minus 0. So minus 1 by pi e raised to minus 2 pi minus 1. So my final value of a0 is, if I keep a minus common, then 1 minus e raised to minus 2 pi upon pi. Okay. So this is the value of a0. Students, is anyone have any doubt for the value of a0? Any doubt, students? Okay. So for the value of an, okay. Now for the value of an, 1 by pi 0 to 2 pi f of x cos nx dx, right? Now 1 by pi 0 to 2 pi f of x is e raised to minus x cos nx dx. I am going to ask you now, what is the next step? What is the next step? Please raise your hand. Yes, Yogesh.
e raised to minus x upon a square plus n square.
So what is our A? Our A is minus 1.
A is minus 1.
So minus 1 square plus n square. Right? Now,
Yes.
now,
Minus cos nx
yes.
plus n sin nx.
Okay. Okay. Thank you, Yogesh. And the limits are? 0 to 2 pi. Okay.
0 to 2 pi. Okay.
So 1 by pi. After substituting the upper limits, I have e raised to minus 2 pi upon 1 plus n square. Here, cos 2n pi is 1. So minus 1 into 1. And sin 2n pi is 0. So n into 0. So this is for the upper limit. And for the lower limit, e raised to minus 0 upon 1 plus n square. Here again, minus 1, cos 0 is 1 and sin 0 is 0. Okay, so this is for the lower limit. Now, 1 by pi, here minus e raised to minus 2 pi upon 1 plus n square, right? And here minus minus plus 1 upon 1 plus n square. So my final answer for an is 1 minus e raised to minus 2 pi upon pi 1 plus n square, or you can write n square plus 1 also. So this is the value of an. And similarly for bn, so for bn 1 by pi 0 to 2 pi f of x sin nx dx. So 1 by pi 0 to 2 pi. Our f of x is exponential term, that is e raised to minus x sin nx dx. So what is wrong? Krish, I am going to unmute you. Yes, Krish, what happened?
Yeah, ma'am. Then where will the 1 upon 1 plus n square part go?
Sorry. Here, e raised to minus 0.
Okay. We take it as common. Okay. Got
Yes,
it.
yes.
Yeah, got it.
Got it? Okay, thank you. Okay, so students, the formula for the Bn, and here I am substituting the value of f of x, that is e raised to minus x. Now, the integration of this e raised to minus x sin nx is e raised to minus x upon minus 1 square plus n square and minus 1 into sin nx minus n into cos nx. Okay, and the limits are 0 to 2 pi. Okay, here a replaced by minus 1 and b replaced by n. So 1 by pi. Here, if I substitute my upper limit, then I have e raised to minus 2 pi upon 1 plus n square. This sin 2n pi is 0. So minus 1 into 0 minus n. Cos 2n pi is 1. So 1. This is for upper limit. And for lower limit, e raised to minus 0, 1 plus n square, minus 1, sin 0 is 0, minus n, cos 0 is 1. So this is for the lower limit. Okay. Now, after simplification, I have this first term is 0. 0 minus n. N into minus n into e raised to minus 2 pi. So minus n into e raised to minus 2 pi. Students, please keep in mind, most of the students forgot to write this minus sign. Okay. So minus n into e raised to minus 2 pi upon 1 plus n square. And here minus minus plus. Okay. So plus 1 upon 1 plus n square. Now, if I take 1 plus n square as LCM, then my answer here n. Okay, if I keep n upon 1 plus n square common, then n upon pi 1 plus n square. I put this n upon 1 plus n square common, then the remaining term is 1 minus e raised to minus 2 pi. Okay, so this is the value for Bn. Students, have you any doubt for the value of Bn? Have you any doubt, students? No. Okay, so we'll move ahead. So the formula for Fourier series is a0 by 2 summation n1 to infinity an cos nx plus bn sin nx, right? Now, what is the value of a0? Our value of a0 is 1 minus e raised to minus 2 pi by pi. Then this for the value of an, and this is the value of bn. Okay, so value of a0, that is 1 minus e raised to minus 2 pi whole by 2 pi plus summation n 1 to infinity. The value of an is 1 minus e raised to minus 2 pi upon pi into 1 plus n square. See, 1 minus e raised to minus 2 pi into 1 plus n square. And this is for bn into cos nx, right? And same for summation n 1 to infinity. The value of bn is n 1 minus e raised to minus 2 pi upon pi 1 plus n square into sin nx. This is for the e raised to minus x. So students, this is the, it's up to you. You may put e raised to minus x, or you can continue with f of x. So this is the Fourier series for the function e raised to minus x. No need to more simplification. So got it? Or any doubt? Okay, thank you, Dia. Okay, students. So today we did two examples with the exponential function. Okay, and we convert our exponential function in the Fourier series. Right? Now we move ahead with the discontinuous function. Okay, we move ahead with discontinuous functions. If we have given discontinuous functions and we want to convert it into the Fourier series, so let's take an example. Suppose our question is find Fourier series f of x is equal to, wait a minute, for f of x is equal to minus 1, 0 less than x less than pi, and is equal to 2 if pi less than x less than 2 pi. Okay, students, in this case we want to find Fourier series, and our given function is, our overall integral is 0 to 2 pi, right? But function is discontinuous at pi. Overall integral is 0 to 2 pi, but function is discontinuous at pi. So, in this case, this is again a simple example of the discontinuous functions. Solution, our original formula, that is a0 by 2 summation n 1 to infinity an cos nx plus bn sin nx, right? Now let's start with formula of a0, that is 1 by pi 0 to 2 pi f of x dx. So students, here our integral is not continuous, right? So 1 by pi, so we divide it into 0 to pi. For 0 to pi, our function is minus 1. So minus 1 dx. And for pi to 2 pi, okay, for pi to 2 pi, our function is 2. So we apply, in the place of f of x is 2. So 2 dx. 1 by pi is common for both. So 1 by pi, as both term are constant. So integration of minus 1 is minus x. So I keep minus sign out of the bracket. That is, limits are 0 to pi. For the same, if I keep 2 out of the integral and the integration is 1 with respect to dx is x. So here x and the limits are pi to 2 pi. Okay. Now a0 1 by pi. If I keep my upper limit and lower limit for the first term, then minus and keep it same. This pi minus 0. If I keep my upper limit, that is pi, minus lower limit, that is 0, pi minus 0. So I have pi, okay, plus 2. If I keep my upper limit, that is 2 pi, my lower limit, that is pi. So 2 pi minus pi is pi. So 1 by pi. 2 pi minus pi is again pi. So finally, my value of a0 is 1. My value of a0 is 1, right? I think it is very easy. So no one have any doubt regarding it. If you have any doubt, please confirm in the chat box, okay? 1 by pi for an, 0 to 2 pi, f of x cos nx dx, right? As we know, our given function is discontinuous. Mayank, please off your video. 1 by pi, 0 to pi. As our function for 0 to pi is minus 1 into cos nx plus into dx, right? Plus pi to 2 pi. At that time our function is 2 into cos nx dx. This 1 by pi is common for both. So 1 by pi, students, minus 1 keep it same, it is constant, and the integration of this cos nx is sin nx upon n, and the limits are 0 to pi. Similarly for the second term, 2 is constant, and the integration of this cos nx is sin nx upon n, and the limits are pi to 2 pi, right? Now, this is 1 by pi. If I put my upper limit, that is sin n pi, and as you know, sin n pi is 0, so 0 upon n is 0, minus, if I put 0, then sin 0 also 0, plus 2 for the second term. If I put my upper limit in the second term, that is 2 pi. So sin 2n pi. Sin 2n pi is 0. So 0 upon n is 0. Minus, for the lower limit, that is sin n pi, which is again 0. All terms are 0. So my final answer for an, that is 0. Right? Now, move for the value of bn. That is bn equal to 1 by pi 0 to 2 pi f of x sin nx dx, right? So 1 by pi for 0 to pi function is minus 1 into sin nx dx plus pi to 2 pi. At that time our function is 2 into sin nx dx, okay? And this 1 by pi is common for both the term. So 1 by pi, as minus 1 is constant, the integration of this sin nx with respect to x is minus cos nx upon n, right? So minus 1 here, minus cos nx upon n, and the limits are 0 to pi. If I keep these two out of the integral, again the integration of this sin nx is minus cos nx upon n, and here the limits are pi to 2 pi. Now, I'm going to apply the limits. So minus minus plus, right? Minus minus plus. Cos n pi. Students, as you know, value of cos n pi is minus 1 raised to n upon n minus, here this minus minus plus. So first I apply upper limit minus cos 0. Cos 0 is 1. Okay. Here plus minus is minus. This 2. Now if I apply the upper limit with the second term, that is cos 2n pi, and cos 2n pi is 1. So 1 by n minus, if I apply my lower limit, that is cos n pi, that is minus 1 raised to n upon n. Okay. Now 1 by pi, this is minus 1 raised to n upon n. Here minus 1 by n, this is minus 2 by n, and here minus minus plus 2 minus 1 raised to n upon n. Okay. So here first and last both term are same, and the middle both term are same. So finally here 3 minus 1 raised to n upon n and minus 3 by n. So if I keep 3 as a common, 3 pi by n common, then the remaining term is minus 1 raised to n minus 1. Students, here first and fourth term will give answer 3 times minus 1 raised to n upon n, and here minus 3 by n, this both term give. So if I keep 3 by n common, then minus 1 raised to n minus 1 left. So this is the value of Bn. Have you any doubts, students, for the value of Bn? Have you any doubt? Okay, okay. Many students give the answer that they have no doubt. Okay, thank you. So we'll move with the substitution of the values, that is f of x is equal to a0 by 2 plus summation n 1 to infinity an cos nx plus bn sin nx, right? Now, what is the value of a0? The value of a0 is 1 here. Value of a8 is 0. And this is 3 pi by n minus 1 raised to n minus 1, right? So value of a0 is here 1, 1 by 2, summation n 1 to infinity. Students, here value of an is 0. So 0 into cos nx, 0. So no need to write this first term. We just directly put the value of bn, that is 3 pi n into minus 1 raised to n minus 1 into sin nx. Okay. So no need to write the value of f of x here. Okay. We just continue with f of x. So this is the Fourier series for your given function. Have you any doubt? This is the Fourier series for the given discontinuous functions. As our function is discontinuous, we did the two integration same time. Okay. So student, if you have any doubt for today's lecture or any query, then confirm me in the chat box. In today's lecture, we did two types of example. First is the exponential function, and the other one is the Fourier series for the discontinuous function. Okay. So I just remind you in first lecture, intro of Fourier series. In second lecture, we did Fourier series for a continuous function with limits 0 to 2 pi, right? In third, it means in today's lecture, we did the deduction of Fourier series for exponential function and discontinuous functions. Okay. Yesterday we did Fourier series for continuous function, and today we did the Fourier series for the exponential and discontinuous functions. Okay. So I will give you one example to you for the homework. Write down, find Fourier series of f of x is equal to minus pi 0 less than x less than pi and x minus pi for pi less than x less than 2 pi. Okay, find Fourier series of f of x is equal to minus pi 0 less than x less than pi and here x minus pi for pi less than x less than 2 pi. Uh, One announcement for you, for all of you. You have to make a note of mathematics 1. It is compulsory. I will ask from any students uh, in the next month. Okay. So you have to keep a full notebook of mathematics 1 of every lecture with your homework. Okay. So if no one has doubt, then you may leave you may leave the meeting. Okay. No, I don't want the basic math notebook. I just want the mathematics 1 from this chapter. Okay. You, you may leave. You may leave. Okay. Thank you.